Hello and welcome to this episode of Math with Martinez. We are looking at our final video in this series on cubic and cube root functions and equations in our Algebra 2 Unit 7 set of videos. We're looking at solving our cube root equations that involve rational exponents. So let's go ahead and dive on in. Rational exponents. Let's talk about those. Expressions with rational exponents can be rewritten as radicals using these rules below. See, a rational exponent is just this that we see right here. It is an exponent that's not just a single integer value, but instead it's this little ratio in that exponent position. And so if you had some base a raised to the 1 over n, what that means is that we're taking the nth root of a. I always like to emphasize this with my students. When you're looking at your rational exponent, the number on top is the power, and the number in the bottom is the root that you're taking. So the number on top is the power in your rational exponent, and the number on the bottom is the root. And the way that I remember this, that it is the root on the bottom, is because roots of plants are always in the bottom. Right? Isn't that true? Where are the roots for plants? They're at the bottom of the plant. And so that may be able to help you remember that if you have, like we say here, in the denominator portion of our rational exponent, then what that means is we're taking the nth root of a, and the way that we would express that is to say that we're taking the nth root of a, where n is our index. Similarly, if instead we have something like this, where we have a rational exponent with a value in the numerator and denominator of that exponent, then what we're doing is we're taking the nth root, that's the value in the denominator, and we're raising it to the m power. So again, remember that the number in the bottom is the root, and the value on top, that's the power. And so that's how you would express that in radical form. So having that in mind, we're going to be able to solve equations with rational exponents, because any equation that is in this form, x being raised to the 1/3 power equaling some value k, that's a radical equation that can be solved by raising each side to the reciprocal power. So what would that look like here? If I have x to the 1/3 power equaling k, then what I need to do to solve this is raise all of this to the reciprocal power, which means I need to raise it to the 3 over 1 power, or I need to cube it. I need to cube it because the 1/3 means I'm taking the third root. This 1/3 means I'm taking the third root because the value in the bottom is the root. So I need to do the reciprocal operation of cube rooting, and that is to cube both sides. So let's go ahead and try to apply that here to this example. We are going to solve this equation. Step number 1, remember always, step number 1, what we need to do is we need to isolate our cube root on one side of our equation, or better said, not our cube root, but our expression raised to the rational exponent. Okay, so I need to look here and see, is that expression raised to the 1/3 power all by itself? No, not quite. What I'm going to need to do here is undo that 4. I'm going to need to undo that 4. And how will I undo that 4 that's in front of that group? Yeah, we're going to need to divide each side by 4. And that's going to give us this equation. Then step number 2, we're going to raise each side to the reciprocal power. So I'm going to take both sides and I'm going to raise them both to the reciprocal power. So the reciprocal of 1/3 is 3/1, but I don't need to really write the 3/1 because dividing by 1 is understood. So that is going to cancel the powers out on this side. Those powers are going to get canceled out, and so we'll be left with just the 2x minus 4, and 2 cubed is 8. Now we're ready to solve that remaining equation. How will we do that? First step, yep, going to be to add 4 on each side, giving us 2x equals 12, and then divide by 2, so that x equals 6. Last but not least, let's make sure that we check. If we take and plug in 6 and where the x is, it should equal 8. So let's see what this simplifies to. Let's grab our calculator. All right, and we're going to take 4 parentheses 2 multiplying with 6 minus 4, and all of that outside of that parenthesis. Now I'm going to raise it by clicking the little caret key. I'm going to get my fraction using my green button and then the button right next to it that says frac, and then raise it to the 1/3 power. And what does that give us? It does give us 8, which is what we were looking for. So that means that 6 is the solution to this equation that involves a rational exponent. Y'all, if you had any questions about working with rational exponents and solving equations that include them, would you please take a moment to share those now? And until next time, stay fired up.